We are going to continue on with our study of bases other than e, and this time we are going to focus on a different learning target: differentiation and integration of exponential functions that have bases other than e. So got a theorem, got some examples, things like that. Theorem 5.13, derivatives for bases other than e. Let a be a positive real number where a is not equal to 1, and let u be a differentiable function of x. Now, the first rule, kind of a rule that is just not going to be very useful for us. It says the derivative with respect to x of a to the x power equals the natural log of a times a to the x power. The reason this rule is not very useful is for the same reason as some of our prior rules were not very useful, because it's not very often that our exponent is just going to be x. So instead, the second rule, the derivative with respect to x of a to the u power equals the natural log of a times a to the u power times the derivative of u with respect to x, is going to be far more useful for us. However, I'm going to rewrite that rule, and I'm going to show you why. If you take a look at the review notes on our curriculum map, let's go back to this rule right here. The derivative with respect to x of e to the u power equals e to the u power times u prime. Believe it or not, this rule is actually the same as this rule. The only difference is, in this rule, our base is e. In this rule, our base can be any real positive number. Now, e is a real positive number, and you can use this rule to take the derivative of e to the u power. What would that look like? Well, let's go back to our notes here. Let's just say that I wanted to take the derivative with respect to x of e to the u power. Our rule that we've used is that this is equal to e to the u power times u prime. Technically, there was something that I had not mentioned earlier, but we also technically multiply this by the natural log of our base, which is e. But the natural log of e equals 1, which is why we don't write that when we are taking the derivative of a function that is base e, and it just ends up being e to the u power times u prime. Now, when your base is something other than e, if it's an a value where a is a positive real number, then I would encourage you, instead of using that rule, make it easier to remember. So if the derivative with respect to x of e to the u power is e to the u times u prime, technically times the natural log of e, let's use that same pattern and say that the derivative with respect to x of a to the u power is a to the u power times u prime times the natural log of a. So it's the same rule, but because our base is not e, we have to have that extra part on the end there with the natural log of a, where a is a positive real number. So if I go back to the curriculum map and the review notes, you can see that the way I write the derivative rule with respect to x of a to the u power is exactly as I just wrote it on our notes there: a to the u times u prime times the natural log of a. And this is a product, so the order in which you write it really doesn't matter. But it's easy to remember this rule and this rule because they're really the same rule. We just don't put the natural log of e on the end of that one. Some examples of this. Find the derivative of each function. So number one, y equals 2 to the x power. if we want to take the derivative of y equals 2 to the x power, that is a function where the base a is 2, the positive real number. So our derivative is really quite simple here. It is going to be y prime equals 2 to the x power times the derivative of x, which is just 1, times the natural log of our base, which is 2. So we write our answer. Natural log of 2 is just a number, so that becomes our coefficient out front here. Typically you will see something like that written with parentheses around it. Excuse me. Times 2 to the x power. Our second example is y equals 2 raised to the 3x power. So this is a more common example, something you would see because the exponent is not just x. The rule, quite easy to use. As long as you recognize that this is an exponential function with a base of 2, y prime is going to equal 2 to the 3x power times the derivative of 3x, which is just 3, times the natural log of the base, which is 2. Now the way that we can rewrite this, there's a couple of ways, and using your properties of logs is going to come in handy here. So you would start by saying 3 times the natural log of 2 is our coefficient. So 3 natural log of 2 goes out front, and we can put parentheses around it to make sure we know that is just a coefficient, times 2 to the 3x power. Where do the properties of logs come in? Well, this 3 out front here, you could kick up and make the exponent so that this becomes the natural log of 2 to the 3rd power times 2 raised to the 3x power. And you can go one step further because 2 to the 3rd power is the natural log of 8. Times 2 raised to the 3x power. All 4 of these are equivalent answers. Any one of them could show up on a multiple choice. You can see that the scanned in answer has our second one there. So the level to which the multiple choice goes it really varies, but you could definitely see this written multiple ways. I'm just going to circle this one as a potential answer. And that's how you take the derivative for bases other than e. Here's our integral rule for bases other than e. And it is once again very similar to our integral rule for exponential functions where the base is e. The only difference is we have to have that 1 over the natural log of a in front of our a to the x power. Why? Once again, if the base was e, the natural log of e would be 1. So this part right here, the 1 over the natural log of e, if our base was e, would just be 1, so it wouldn't be needed. So we have one example, and this is kind of a rare type of integral. It does happen from time to time. So if you were going to integrate 2 to the x power dx, there's no need for a u sub because x is by itself in the exponent spot. So this integral is going to be not just 2 to the x power, but in front of this we need 1 over the natural log of 2. Plus c. And you can see the scanned in answer has the same thing there. This rule is highlighted on the Unit 7 curriculum map right here. And if you did have a function that was more complex than just x, you would have to use a u sub for whatever was raised to the power as well. Again, that's somewhat rare. This is one of the less used integral rules, but it is one that we will see from time to time. The big derivative and integral rules for the AP test are the derivative of the natural log of u, the integral of 1 over x dx, the derivative of e to the u power, the integral of e to the x power, and the derivative of a to the u power. So to put it all together, we have 3 examples down here, and they all look pretty simple, but understanding what they all represent is important. So the first example here, the derivative with respect to x of e to the e power. Be really easy to make a mistake with this one if you didn't recognize that e raised to the e power is simply a number, 2.718 approximately, raised to 2.718 approximately. So this is simply asking you to take the derivative of a constant. The derivative of any constant is 0. So just because you see a base e does not mean that you use the derivative rule for e to the x power. If e is the only thing in the function, then you're simply looking at a constant. Number 2, it is exactly what you would expect it to be, e to the x power. You're going to use your derivative rule, so the derivative of e to the x power is e to the x power, technically times the derivative of x, which would be 1, but I'm not going to write that. There's our answer. And then when we go to number 3 here, we see an e, but this is actually a polynomial. Normally we see x squared, or x to the third, or x to the negative second, but this time it's x to the e power. So you're going to just use the power rule for this one. So there's a 1 out front of this x. When we take e times 1, we get e times x. And then how do you drop e down 1 degree? E minus 1. So our derivative of x to the e power is e times x raised to the e minus 1 power. And you can see the answers from the scan-in solutions below. Same things that we got. Just have to be real careful with e's, because depending on how the function is written, you could just have a constant, you could have an exponential function, or you could have a polynomial function. So the derivative rules are different for each of those functions.